Antonio, you can start.
All right. So good afternoon, everyone. Thanks for being here today, this Wednesday afternoon. Um, yeah, somebody is coming here. So this is my presentation for today. Is called the Structural Wood Masonry Design Open Educational Resources Manual and Recovery for COVID and Construction Industry. I'm an assistant professor from the Civil Engineering Department at Savannah State University. And me and my colleague, Dr. Maciar Moveni, we are working on this project funded by the University System of Georgia. This is funded by this agency to produce an open book textbook for the labor force in construction in the Georgia area pretty much, but overall wide country as a whole, no, as a general idea. All right, so the objectives of this quick talk, is going to be understand the impact of the effective hands-on open education resources learning tools to prepare students or apprentices to become familiar with codes, standards, specification, commonly used in design of timber masonry structures and edifications. So here the goal is to get some clue, some flavor of what this industry is all about, construction industry in the United States, how it has been affected by the COVID-19, by the contingency, the health contingency. What can we do in terms of the open resources avenues, which niches of opportunity we can have to really improve and help the labor force in the country. Also, we want to understand some general practices and general licenses, professional engineering licenses that these labor force have to comply in order to really do the work, not to be able to do the insert themselves in the construction industry. And also recognize some key concepts and techniques and examples of what we are doing here in Savannah State University to try to accomplish and try to contribute with a small grain of salt on this encompass, on this coronavirus. Generalities of the talk is we want to obviate a type of application of open education principle during the COVID-19. The proposal is also intertwined with the this so-called for the conference, exploring intersection and collaboration across borders and contexts. So this talk is very specific to civil engineering. It's not mainly focused on general education, but mostly on this niche of civil engineering that I'm talking about. Open education is changing abruptly in recent months as a result of this transition online education. So we have seen some transition, some really niches of opportunity for doing online teaching, online educational training, continuing education, doing online, interactive online, even go beyond for the upcoming years to virtual reality, virtual environments to really help this labor work that has tight problems with the unemployment to now raise, get a nice job, get a well-paid job, and then recover from this contingency. No, that's the idea. The proposal also emphasizes these driving practices to open source hand-on technological scholarly materials, and also to reinforce and to prop up the curricula in these 4 college engineering curricula that we are working, my colleague and I. No? Okay, let me go straight to the basics. Probably most of you don't have this background in engineering, but let me go. I'm not gonna go technical, but this is gonna be more like a relaxed talk. But still, I want to give you some of the background. What is civil engineering? Civil engineering is, yeah, sorry, I'm sorry, yeah, to invite some people here. Civil engineering is a professional engineering discipline that deals with the design, construction, maintenance of physical and natural built environments, including public works such as roads, bridges, canal, dams, airports, you name it. No? It's all about infrastructure, is the backbone of the society. Civil engineering is nothing but infrastructure, construction, high, intensive, massive construction, edifications, etc., etc. Different branches of civil engineering are environmental, transportation, water resources, surveying, construction, geotechnical, and structural. So today I'm going to focus on structural engineering. This is my field of discipline. This is my field of expertise. Some people want to join the talk, but yeah, I'm sorry for the delay here. I'm sorry for the delay. Okay, so you have this big spectrum, no? For the civil engineering degree, we have typically it's about 3 or 4 years length, sometimes 5 years length. When you want to do dual accreditation in construction and maybe structures or construction geotechnical, but it's typically 4 years, a 4-year ABET accreditation curricula. It is offered the bachelor's in engineering and bachelor's of science. And you can also have masters in engineering, maths, and science, and you can even have PhDs and all sorts of layers of education on civil engineering. The general curriculum, in general terms, is composed of, in the freshman year, about physics, mathematics. And then you go to the junior, sophomore years, you go to more project management courses, light construction, some basics of civil engineering. And then in the senior year, you go now deep on your field of expertise, such as transportation courses, geotechnical courses, mechanics of soils, and all the magic, all the magic of engineering, you go there. So this is pretty much the scope of the curricula for civil engineering. But once you pass and once you get your degree, the next step to really be in the task force, you have to pass these 2 filters: the fundamentals of engineering exam and the so-called here professional engineering exam. So these are really the bottleneck for most of the engineering practitioners in the country, and even in several countries around the world. Okay, let me just continue here. The common bread of civil engineering comprises project planning, hydraulics, means and methods, geometrics, soil mechanics. This is like the minors, no? The general skeleton of the curricula, civil engineering curricula. And then we have now focalized niches such as construction, transportation, geotechnical, water resources, environmental, and structural. So you see it's a kind of very broad spectrum, very well-established clusters of knowledge that you can intertwine each other, but you have very specific areas where you want to really interact and you want to really create something for them in the terms of open education. No? That's the idea. Okay, so continue with the talk. What this fundamentals engineering exam is all about? Well, it's administered by this institution called the NCEES, Advanced Licensure for Engineers and Surveyors. It's like an accredited country institution that really administer the exams on computer-based exam or pencil or face-to-face pencil examination. Is the first step to really become a licensed engineer in the country. It's not that difficult, this exam, but you have to have pretty much a strong background in bachelor's degree, no? And that's the idea. Typically, it's only accepted by accredited institutions in the country. The ABET accreditation, this ABET accreditation thing is the standard accreditation in the United States to really establish if a university really are complying with a minimal quality of education or is really beyond the level, no? So that's the idea. So in order to be able to present this exam, you have to be a graduate for an ABET accredited program. Savannah State University is an ABET accredited program. So computer-based exams. Typically, this exam comprehends, or the scope of this exam comprehends, the general core, the general spine core of the curricula, and then you just go to specifics. No? Here, I'm going to talk about the structural engineering, just in a minute. All right. So it's pretty much the thing. Now, once you pass the fundamentals engineering exam, now you need to go now to a more tougher, I would say it's one of the toughest exams in engineering, the professional engineering exam, this so-called principles and practice of engineering exam. So why is this important in this exam? Because in order to really practice and have legal credentials to exercise your engineering expertise, you have to be licensed by this professional engineering exam. It's again administered by this institution. But this exam is tough, but not only is tough, but it's expensive. It's quite expensive. You spend at least $2,500 just to be able to present, and if you fail, you need to spend another $2,500. It's a book, the training book is like a Bible. I'm talking about maybe 2,000 pages of heavy content, heavy material content. You really need to really review and learn, little by little. You will need probably at least 3 months, 4 months to prepare for the exam. Typically 1 year, maybe 2 years. And it's a tough exam. It's 16 hours long, the exam, and comprehends all sort of components in the civil engineering. Let me just put it quickly. The idea is critical for career development. Whoever has a PE, a professional engineering license, you can get a quite nice job, very well paid, and you can maybe pursue, high-level positions, director positions, supervisor positions quite easily. So it's a very good investment for engineers that want to continue your professional education and their professional career. PE demonstrates heightened leadership in management skills. Licensure is also a necessity for rising to increased levels of authority and responsibility. So as you can see, it's a quite ambitious exam, but it worth the effort, as I mentioned. The problem is that, let me explain what is the problem. The problem comes from, once we have this coronavirus decline of jobs back in, April, June, we lost a lot of jobs. And the problem is that when you want to apply for the process of retaking your job, having a job again, back again, sometimes you have to pass to a new filter, which implies this professional engineering license. So engineers that didn't pay attention, or simply they forgot to renew a license or apply for a license or pass this exam, now they will face big problems to jump or to insert themselves again in the workforce, and that's creating like a bottleneck right now, that the unemployed people doesn't have the resources to do that, doesn't have the time to sit down and study 1,000 pages of heavy material. So we have a problem there that we want to really alleviate somehow, or really contribute somehow to help these people to really overcome the challenge. The exam, the licensed professional engineers tend to earn significantly more money, as I just mentioned, but tend to be more trained or more qualified engineers. Out of all the engineers in the United States today, only about 820,000 have a PE license, the whole country, which is very low. I'm talking about out of every 9 graduates and get the PE license. So you see, the accreditation rate is very, very low. So what we need here, increase the rate. We need to create some type of scaffolds, tools, resources, motivational thing, workshops, seminars, webinars, you name it. We need to apply all types of resources to really help increase these standards, because they're too low. Professional engineer's license is very emphasized today for very well-paid jobs and stable jobs. Now, the companies that hire the engineers, they request for professional engineering license. Otherwise, they pay you half your wage, your aspired wage. And in general, professional engineering licenses are renewed every 2 years. This is the other problem, that once you get the license, now you need to renew every 2 years, and you need to apply for continuing education, seminars, webinars, conferences, and sometimes even you need to reapply for the exam. If you delay too much, or you forgot to get this so-called PDH, which are called professional development hours, that you need to comply every year. Like attending a conference, now you get 3 points PDH. Attending a webinar, now you get 3 points PDH. Attending a seminar, and so on and so forth. That engineers that lose track of this PDH, they get delayed, and after some period, after 5 years, you lose your license. And now you need to reapply again, retake the exam again, and maybe you fail, and then you lose your license, and you lose the job, you lose the salary, you lose everything. Upon the coronavirus. So it's so critical. This is so critical, this part for the civil engineering community, and also worldwide. Look at this table here, for example, several countries, for different countries, you have the equivalent accreditation, license accreditation in Alberta, Canada, Egypt, Japan, Korea, England, Nova Scotia, Taiwan, Turkey, and others, with equivalent exams, equivalent examinations to really, filter out people and put the bar high for this license accreditation. Topics in this exam cover all this material that you can see there. So it's very broad, it's very intensive. As I mentioned, it's 16 hours long used to do this. So it's quite a challenge. You have to have a very nice breakfast, maybe sleep 2 days after, prepare for the exam, and accommodate the whole thing. So you just spend 2 days closed door to resolve the exam continuously, heavy material. And today I'm going to talk about this again, the structural part, which is in fact is the most difficult part amongst all these branches that you see. Structural is the most difficult. In fact, in a structural, you have to apply 2 exams, not only one. One is for the general civil, this one is for the structural, which means that you will have to have even more high standards. What's the reason? To protect people, to build nice structures that are safe for everyone, that are on their a lot of regulatory standards against earthquake, against hurricane, against tornado, against flooding, against explosions, terrorist attacks, you name it. So that's why it's so challenging. So let's see here quickly some stats from the Bureau of well, for this exam. Look at the different branches. Number of first takers from this year. Take a look at this. For example, in construction, only 678 people apply this year. It's very small. For chemical, look at the chemical, it's 125. Look at the others, I don't know, architecture, another architecture. But now look at structural. You see that? Why? Why is the case? Because if you work in a mining industry or the mechanical industry, you probably don't need a PE license to work. Sometimes maybe you can, but sometimes maybe not. It's variable, depends on the company, depends on the state, etc. But for the structural, it's like a standard. You don't have the exam, you're nowhere. Simply as nothing. So everybody, all the structural engineers have to pass the exam. And look at the rate, it's only 63%. And it's the first taking. No? When you take it for the second time, now it's only 41%. And it's only available twice per year. You need to wait just 2 shots per year to really present the exam. So that means that you can get in trouble, in financial troubles if you don't get the job because you don't get the license, as you can see. So it's very stressful. So that's why we need to invest time and really to invest resources to really help these engineers to overcome this challenge. No? Look at this table again. It's another similar situation. And, how do you fail? You look at the rate of failing now for the part of the structural engineering alone. Look at this, it's just 33% approval rate. In the second test, it's just 28%. So this is really bad numbers. No? These are really depressive numbers. So this is the niche. Clearly, we have a niche that we work on open education, and I will explain just in a minute how is that about. This structural exam comprehends these topics. Let me go very quickly on them. And one of the topics that are forgotten, like no priority, are this one: wood design or masonry, wood or lumber design, houses, no? This real estate housing, churches and formwork structures, etc. And the masonry design, which means brick design, no? Like brick low-rise buildings and governmental buildings, high-rise buildings sometimes, etc. So typically you have 2 big niches. The most important niches in structural engineering are steel and concrete. And people tend to forget this one because they think that this is not priority. Well, certainly is not priority when you have a nice economy, when you have really a lot of money injected in the system to really build in a massive construction in steel and concrete. But when you are in a contingency, in a health contingency, coronavirus, and you have a very high rate of unemployment, you need to resort to now you need to lower their standards and maybe search for real estate industry, like low-rise construction, home construction, housing construction, you know, this type of work. And in this niche, all the construction work is about wood and all the construction is about masonry, not steel and concrete. So engineers forgot to learn these topics, and then they pay the price when they get unemployed. So these topics are, even though no priority for high, very well-paid jobs, are very nice when you are unemployed and when you want to work as a self-employed, no? in a case of contingency. So that's why my colleague and I are focused on prepare an open source material to teach and to deliver a textbook, open textbook for the public. So the people that doesn't have the resources and doesn't have the time to prepare for the exam, they can really learn by just practical examples, heuristic examples very quickly, learn the topics, train themselves very quickly, and then face off the exam. And hopefully they can pass the exam. No? Again, it's a small contribution, open source. Why we want to do this an open source and open for everyone? Well, because look at the cost. This is what this institution charges. It's $37.5 for just have access to the exam, computer-based exam. Some practices, the exams and lecture notes, $100. And then you have the manual, $240. And then you have some accessory items, no? Your calculator, because you cannot use computer or cell phone. You have to go to your calculator, so you need to buy a calculator here, ridiculously enough. And then look at the manual. This big, the $1,000, the 1,000 pages manual is $1,200. So in the total, when you add them up, all the whole thing, the cost of the exam is about $2,400 plus hours, days, probably months of reviewing and learning and practicing the stuff. So you see, it's quite a challenge, no? So we want here to contribute a little bit to help this, to alleviate this stress. The motivation, very quickly, because I don't have time. Little information is available for free. There's almost no free instruments to help these people out. Preparation materials are monopolized by these companies. There are some, like 3 or 4 companies that really control the exam, and they offer very expensive packages for the open public to really take the exam. So it's a very controlled, like a cartel thing, group of people that they want to really keep the whole thing. So we want to really open resources, open the gate for everyone, not only for these monopolized companies. Very little information is about masonry and wood design, besides some general books, but there's very little information, very little resources available for free for the people. So we want to again contribute a little bit in this line of thinking. No? Some very quickly, I just have 2 minutes. So some general graphs of the unemployment for the past year. You got probably, you know, you have seen these graphs before. I'm just focusing here on the construction industry, how we have lost jobs. Look at how the jump in jobs in April, and how we are now really overcoming little by little, recovering the jobs. But again, this is like lagging a little bit. It's not as we wish we were at this point in time. Some other statistics from the Bureau of from the Bureau of Labor and Statistics. I'm sorry. And well, this project is also funded by the University System of Georgia under the Alternative Text 2020 grant. The objective here is to develop an effective, productive, and compelling textbook and complementary software. We want to build some kind of app that help the student to really learn and to really understand, interact with the material and the app. That will be the overall goal for next year. And with the two main objectives: alleviate the financial burden of the apprentice and provide a high-impact, self-reliant, self-learning, pedagogical, interactive tool in wood masonry design towards the preparation of this professional engineering exam. So that's the goal of this project. And let me throw you some the content of this textbook that I'm working on right now. I'm halfway through with my colleague. This is pretty much the content of the textbook. some general chapters, good design requirements, good intention, good completion. But this is very technical. I don't want to go to the technical thing, but just to give you some glance of the work that we are developing right now, some screenshots of the textbook that you can see. Here I'm taking information, for example, from Home Depot, quickly on point, hands-on instrumentation and information for the apprentice to really learn how to really do the real thing, do the heuristic, the practical thing, and then just solve some handwritten examples, step by step, hand by hand, point by point, look at it. And so the student can really observe and really get extra information that you don't get from other books or from manuals and whatsoever. So it's another avenue of or another scaffold avenue for the learner. And
Antonio, I'm gonna have to stop the recording, yes. But if you want to stick around, the room will still be available for another 10-15 minutes for questions and answers. Mm-hmm. So if any of you have any questions for Antonio, please stick around, and thank you so much for joining us.